In this section, we are going to do a small exercise on set-driven keys. Hopefully, through this exercise, we can help everyone better understand how to set up set-driven key. So let's look at my scene. We have a model like this, and we have a controller. We're going to change the values on the controller's attribute and use set-driven key to control the model to achieve a relatively complex transformation effect. Let's take a look first. It's basically an effect like this. So let's do it together. Let's open our model file. Before we actually start, let's first look at the setup in our scene. First, I have a NURBS curve here. We mentioned this before. This thing is a controller. I've already created an attribute for us here called transformation, and it's a float attribute from 0 to 10. We'll be using this attribute to control the transformation effect. Next, let's look at the model. The model here is split into 3 layers: inner, middle, outer. The outermost layer here has 2 parts. One part is our base. The other part is the front shell. The front shell is split into 4 pieces. These 4 pieces are separated so they can do some relatively complex splitting effects. Next is this middle part. This middle part is also split into 3: front, middle, and back. These front 2 parts are also each split into 4 small pieces to do some splitting effects. Finally, there's a tube on the very inside. This tube will be pushed out during the final transformation. Basically, that's the model setup. When we actually go to set up the driven keys for these models, we'll follow the same logic as our previous exercises. When we were doing aim constraints, we didn't do any operations on the model itself. Instead, we created a group, put the model in that group, and then we created extra transform nodes, whether a regular group or a locator. In short, we did our constraint setups on this node we created. Finally, we used these nodes to constrain the final models group to control the model. When we're doing a set-driven key setup, the logic here is exactly the same. The reasons are also similar. First is the same reason as our previous exercise. When we set things up directly on the model, it's very difficult to make changes. Also, our scene will have a lot of extra unnecessary nodes, which will slow down our rig. Another reason is because when we're creating these transformation effects, a lot of the time, we need to define the pivot points ourselves. For example, when we rotate or scale, we might not be satisfied with just operating from the world origin. But our models, when they're created, all of their pivot points are at the world origin, so we don't operate on the model itself. Instead, we create these transform nodes ourselves. This gives us much more freedom. Not to mention, when we're doing more complex effects, we can stack many layers of transform nodes on top. This allows us to achieve complex transformation effects from different pivot points. So now let's do it. Similarly, we'll use locators as our final transform nodes. Because locators can be displayed in the scene, it's more convenient for us to work with and more convenient for me to demonstrate. Here, let's start with the outermost shell. I'll create a locator and copy the model's name, and let's modify it. According to our naming convention, we'll use LOC here. Get rid of the level of detail, we don't need it. Then we can put it in a position we think is reasonable. For example, this position seems about right. We could directly set the driven key on it here, but I personally don't recommend doing that. Why? Because it already has values in its translation, and this position is our initial position. This brings up a problem. If I move it to another position, it will be very difficult to get it back to the initial position, because I no longer remember the initial position's values. And if I have to write down these initial values somewhere just to remember them, then it's already inconvenient. So what do we do? My general advice is to ensure that in our initial position, translate, rotate, and scale are all at their default values. But we generally don't freeze transformations. Instead, we create a group. This is the same logic as when we did the aim constraint exercise. Name this group 0, snap it over, then put the locator inside. This way, you see, it no longer has these values itself. Next, let's do the other 3 parts. The other 3 parts we can see are in the same position, just rotated to different angles. So here, we'll duplicate it. And don't forget to change the child's index. Because when we duplicate, the child's name won't be changed automatically. So what do we do now? We could, of course, move it to the corresponding position. But that's not very convenient. We have a faster way. Because we know these 4 parts are all rotating around the world origin, so we can group it again. Group each one again. Look, when I group it again, this pivot point is at the world origin. So now I can rotate it. And each one has a different rotation value. This way you see, the 4 are in their 4 positions. Next, the parent groups we created aren't necessary anymore. They were just to help us quickly place them. So now let's select these 3 zero groups and press Shift plus P to unparent them. We'll see all those values we changed have been passed down to the zero group. We can delete those 3 temporary groups. To make it easier to see, I'll select these locators and create a display layer. Set it to blue. This way, we now have these 4 locators. And to keep things organized, I'll group them again. I'll just call this group and add locator at the end to show these are all the outer part locators. Then let's create the model groups. This way, we can put our models into this group in a bit and use our locators to control this group to control our models. Let's copy the name over and change its type to trans. And we'll parent constrain them one by one. Uncheck Maintain Offset. Now I have these 4 groups, and we'll put the models in. Okay, so now we can start setting their position and the rotation. Here we can start by posing its final position. Because we know when we zero it out, it goes back to the initial position. So we can adjust its final position first. After we've confirmed the final position, we'll go back and set the keyframe for the initial position. Let's try setting it up. Okay, I think this looks about right. I usually like to clean up the numbers a bit. I don't like having so many irregular numbers. Okay, the numbers are cleaned up. Next, we need to do the other 3 locators. The other 3 locators, we can see their values are actually the same, because the only difference between them is the 90-degree rotation at the parent level. So when, for example, it moves back -2.5 and moves up 0.85, the effect is exactly the same as the part above. The only difference is its direction. So here we can just transfer the values from the first locator to the rest of the locators. To transfer the same attribute value, Maya has a very quick way. How do we do it? We first select the node to be transferred to. Then select the node we already have the value on. Then say we want to transfer translate y. Since they all have this attribute, we just click on this in the value input field and press enter. This way, we'll see the value on the locator being transferred to will change. What if I have multiple values to change? I can select the node to be transferred to, then the original node. Then we start from the first one. Again, go into this input mode and press the tab key on the keyboard. It will automatically go to the next line. This way, look, when we're done, all the values have been changed. Okay, so let's do the others with the same method. We can multi-select. It will transfer the values from the last one selected, which is the node currently displayed. This way, you see all the values are transferred. Okay, that's the outer layer. Now let's do this middle layer. Same thing, create locators. And let's put them in this position too. Let's isolate them. Here I want to rotate it a little bit. This way, when I go to move the z-axis, it moves along the slope of this surface. That effect is a bit better. And same as before, we create a zero group. Snap it over, put it in. And same thing, I'll duplicate 3. Same deal, let's rotate them. Then unparent. Delete the temporary groups and group them again. I'll put these locators on a display layer too. Give it a color so it's easier for everyone to see. And same as before, we start creating the model groups. Put our models in. My idea here is to move these 4 locators back a little bit. Maybe 0.5. We can tweak this later. Because we haven't set any driven keys yet, we're just simply setting their positions to see if the final result looks good. Next are these front ones. Same operation. Create a group. Put it in. Then we'll unparent these 3, delete the temporary groups, and group them again. And create the model groups. Put our models in. And same thing, let's change its position and see what its final result, where we want to put it. I think this is about right. And let's transfer the position to the other 3. Okay, finally, let's do this innermost 2. Same operation. Its current position is already fine. We don't really need to change its initial position. So for this 0 group, we can just leave it at the origin. And same thing, create a model group. Put the model in and move this locator forward. I think this is about right. Since we've set them up, we can now start to set driven keys. The operation is the same as before. Select one of its attributes. It doesn't matter which one. Then open the Set Driven Key interface. Load the controller into the driver interface. We use this Load Driver button. Then we need to find all the other locators and put them all into the driven column. There are a lot of them. We can select them one by one. Or, because they all follow the same naming convention, we can also, as we mentioned when we first talked about naming, select them quickly. In here, find Select by Name. And here we can type starts with LOC, then the side, which is center, then the description we don't know, and the final index. We also don't know, but we know it's 4 digits, so 4 question marks. This way, look, we've selected all of our locators. Then click Load Driven. So all of these locators are now displayed. For all locators, we need to control their translate and rotate. And pay attention here. Because this is our final position, we need to set our driver attribute to 10. Select all of these. Note that we've selected our driver object, our driver attribute, the driven objects, and the driven attributes. Then click the Key button. This way, no matter which locator I select, we can select any node in the Set Driven Key window. and it will also be selected in Maya. We can see that in front of all these attributes, there's a blue color, meaning it's controlled by a set-driven key. So now we have one keyframe. We can't create animation, we need another one. We need it so when it becomes 0, all our values go to 0. Look, now that we've set this up, everything is back in its original place. This is why we needed a 0 group on top. And don't forget, press the key button. Note here, we've also selected all our driven objects, the driver object and the corresponding attributes. Click it. So now let's take a look. We have an animation like this. I think this result is okay. But we can see that on some frames, there's some intersection. First, let's change our curves. Because right now, if we look at the curves, none of these are a constant speed movement. We can select these and click this button and make it a linear motion. This way, first of all, in terms of speed, we've ensured it's a constant change from 0 to 10. Next, we can adjust it in sections. For example, these 4 small parts on the outside, I want them to start moving later. We can find this curve. It starts from 0 right now. We can change it to start from frame 5. So look, when my upper 4 shells have already moved a certain amount, the parts underneath start to move. This avoids a bit of the intersection. Of course, there's still some, but we can look at that in a moment. Then we can adjust a bit more. For example, these middle parts, we can adjust these based on the result we want. There's no single correct answer. For example, here I'll have it start moving at frame 2 and have it finish at frame 7. And let's make the innermost tube move a bit slower too. Let's have it start at frame 6. Now let's take another look at our intersection problem in the middle. We're doing a set-driven key, but it's not like we can only set 2 keyframes. We can also set different settings in the middle. For example, here at this frame it's clearly intersecting, so maybe at 8.5 we can set another keyframe. Let's move it up a little. We can have it rotate a bit more. This is up to you. And let's copy its value over. Here let's select just these 4 parts locators and set another keyframe. This way, if we look, it looks a bit better in this area. I think what we can also do is, at this frame, make these 4 parts at the back. This outer shell move back a little faster. Let's move it to this position to avoid the intersection. This looks a bit better. We could also move these 4 parts a bit more forward to better avoid the intersection problem. Okay, now look. Now this model has a slightly different result. Of course, we can still adjust the curves to make the result even more different. That just depends on your own ideas. Also, if we want to add other effects, we can do that too. For example, we can make these top things rotate. Similarly, we can take a look. Our corresponding locator is current range. We can open our graph editor. Let's see. It goes from frame 5 to frame 10. This rotation I think is a bit weird. I can delete it. This way, let's take another look. Look at the animation. Okay, frame 5 to frame 10. We can do another set-driven key on its parent group. Here, let's just do its z-axis. And let's have it stay at 0 degrees when the value is 5. Then when it's at 10, let's make it 360 degrees. This way, look, it has a different behavior now. We can also do the same operation for the 4 inside. Here, let's have it, for example, start at frame 2. And let's have it say by frame 7, rotate 180 degrees in the opposite direction. Key it. This way, if we look, it has some relatively more complex effects. This all depends on how we want to design it and how we want to operate it. There's no absolute right or wrong. Finally, let's clean up this setup. Select all our locator groups and let's group them again. This group is our rig nodes, and let's put it under the master group and hide it. The rest of these model groups, we can put them back under the model group itself. This way, we've finished a simple set-driven key rig. The rigging operation itself wasn't actually very complicated. Our model itself is also relatively simple, and the effect we set up wasn't that refined. But through this simple exercise, I'm sure we can imagine if we had a more complex mechanical model that needed to do a complex mechanical animation. Like we mentioned before, armor on a person's arm that changes parts and turns into a weapon like a gun or a cannon. These more complex transformation shots in movies can all be achieved using similar methods. And in the end, what we give to the animator is just a 0 to 1 or 0 to 10 attribute. And the animator then decides when to activate this transformation effect. And that's how it appears in our shot. Okay, so that's our explanation for this small set-driven key exercise. I hope this was helpful.